Guys, we're looking at piecewise functions today. Starting out with some vocabulary. Domain, we say, is all of our x's. So all of the x values that a graph covers, versus the range would be all of the y's. And that's going to be important for establishing kind of the constraints on the graph. So domain is going to be running from left to right, whereas range runs bottom to top. Okay, so if I consider my domain as all of my x values, it's going to include all of the x's from these ordered pairs. So we can go ahead and just write those out, that my domain is just simply a list of numbers. So sometimes you do it with braces or parentheses, 3, 5, -10, and 2. Whereas my range is all of my y values. So those are the numbers that come second. -5, -6, 5, and 0. And that's it for the list. So same thing here. Domain would be all of my first values here. So domain, -5, 2, 3, -5. And range, all of my second values. 7, 3, 3, -5. You don't even need to repeat the number, but we'll just, for the sake of thoroughness, do the repeat. So pretty easy when it's discrete. Okay, this next one is telling us that we have an apple orchard, allowing people to come and pick their own apples. Customers pay $5 for a basket and 10 cents for each apple. We have a function that represents the cost for the apples picked, and we want to find the range of the function. So considering that the range is the output, okay, and it's telling us that the function gives the cost, the total cost for apples picked. So we could even plug in some values and see what's generated. So if I put in a 1, let's put it down here. 0.10 times 1 plus 5, that's going to be 0.10 plus 5, which is 5.10. If I put in a 2, 0.10 times 2 plus 5, that would be 20 cents plus 5, which is 5.20. And then if I continue that on, notice that I'm going to have a pattern here. 0.30 plus 5, which is 5.30. Okay, and that pattern is going to continue. If I even put a 0 in, I'm noticing that at the bare minimum I have to spend $5. So that's going to be my list of possible outputs. Okay, it gets a little bit trickier when we try to establish domain and range from a graph. So you want to think of cropping the image. So this is the boundary, or we'll say these 2 points kind of set the constraints. Because domain is from left to right, let's try that one again. These are kind of the boundaries to this graph, right? On the left, let's see, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. That's going all the way to -9. And on the right, it's going all the way to +9. So my domain, expressed as a list, right? Or we'll say an interval, is going from -9 to +9. So it's including all of those values in between. My range, on the other hand, we're thinking of like ceiling and floor. That's as high up as it goes and as low down as it goes. That's ranging from 1 to +9. So my range is going from 1 to 9. So the structure looks a little bit different when I have a continuous, well, it's still discrete, but when it's not just individual points. Okay, same thing with 4. Oh, I realized that's down there. Our domain, right, has a boundary here, and then it's going forever, so there's no boundary on this side, meaning my domain is coming in from -infinity, and it's stopping right here at 5, 6, 7, 8. And we would have a bracket there because it is included. On the other hand, if we're going from 1 to infinity, my range is lower bound at 1, going all the way to +infinity. Cool. Same thing here, looking at restrictions on left and right. So notice that we're right here at -1 for my domain, going all the way to infinity. So I could express that as -1 to infinity. Okay, range doesn't have any bounds at all because it's going forever low and forever high. So -infinity to positive. We couldn't even crop it from bottom and top. Okay. Domain on this guy, again, think of it as cropping it from left to right. So we'd have to have a wall here, which is at -8. And all the way actually to this little foot at 1. So my domain here is going from -8 to 1. Right, because we're saying how far does it span from the left to the right. Okay, range, we're cropping in the other direction. Right, so if we get a different color here, that's going down to -8 and up to +8. Range then, -8 to +8, because we're thinking how is it cropped bottom and top. Okay. This guy, again, range, we're thinking left to right, super narrow constraints there. That's 1, 2, 3, 4 to 5, right? Very tight window. So just 4 to 5. Whereas my range, again, we're cropping in the other direction, is 1, 2, 3, 4, 5, -5, to 1, 2, 3, 4, 5, 6, 7, 8. Right, so -5 to 8, bottom to top. Okay, this guy, domain, again, cropping it on the left. There's no boundary on the right, right? So it's beginning at 1, 2, 3, and going to infinity. And then domain, we're cropping at the bottom here, which is at 0 to infinity, because no upper bound. Cool. Next one, domain. Notice there's no bounding on the left and the right, -infinity to positive. But there is on the range, so that's -2. Sorry, -1, 2, 3. -3 to infinity. Right, because it's going as far down as -3 and then not bounded on the top. Domain, again, getting our boundary lines here and here. That's going from -1, 2, 3, 4, 5, 6, 7, -7 to 1, 2, 3, 4, 5, 6, +7. -7 to positive. And then range is bottoming out at 0. Right, because it's right here at 0, all the way up to 1, 2, 3, let's see, 1, 2, 3, 4, 5, 6, 7. 0 to 7. And there we have it, guys. Thanks for watching.